Hello students, welcome back. Let's have a look at the next set of questions. The first question is, a ray of light traveling in air enters obliquely into water. Does the ray bend towards the normal or away from the normal? Why? The second question is, light enters from air to glass having diffractive index of 1.50. What is the speed of light in the glass? The speed of light in vacuum is 3 into 10 to the power 8 meter per second. And from table 9.3, we have to find out the medium having the highest optical density. Also find the medium with the lowest optical density. So we'll have the table, and then from the table we'll find out the answers to these questions. Then you are given kerosene, turpentine and water. Which of these does the light travel fastest? Use the information given in table 9.3. Alright, we'll do that. Then the refractive index of diamond is 2.42. What's the meaning of this statement? Alright, so let's solve the first question. So the first question says light is traveling in air, obliquely enters into water. Will the light ray bend towards the normal or away from the normal, and why? Now let's see how the light rays behaves when it changes medium. So let us consider two medium and see how light rays behave when they change the medium. So let this be a medium 1, which is a rarer medium, and this medium be a denser medium. So this is medium 1 and this is medium 2. Now when a light ray is entering obliquely, it's striking the interface of these two mediums. So let this be the normal n dash. So now when light rays enter from rarer to denser medium, initially the light ray was supposed to go straight like this. But because there is a change in the medium and the medium 2 is a denser medium, so the speed of light slows down in the second medium, and the light ray which was initially going in this way, now its speed will slow down. So speed slows down and it comes closer to the normal. So this light ray will now come closer to the normal and travel in this direction. Alright, so when a ray of light enters a denser medium from a rarer medium, it comes towards the normal. Towards normal in the second medium. Now let this be a denser medium, and so this is the first medium which is a denser medium, and the second medium which is a rarer medium. So our medium 2 is a rarer medium. Now let a light ray incident obliquely, and at this point let again m dash be the normal at that point. Now light ray is traveling from a denser to a rarer medium. So when a situation like this comes, that light is traveling from a denser medium to a rarer medium, when it enters the rarer medium, its speed increases. Okay, its speed increases. So this was the initial path in which the light ray was supposed to go, and its speed increases in the rarer medium and it bends away from the normal. So now this light ray which was initially going in this way, it will increase its speed in the rarer medium and it will go away from the normal. So this is the normal. This was the initial direction in which light was supposed to go. Now it will go further away from the normal and it will travel in this way. Alright. So now light ray will go away from the normal and it will travel in this way. So from this we understood that whenever light is traveling from a rarer to denser medium, it bends towards the normal. When a light ray is moving from denser to a rarer medium, it bends away from the normal. Okay, the reason being the change in speed. When it enters a denser medium, its speed slows down, so it bends towards the normal, and when it enters a rarer medium, its speed increases and it bends away from the normal. This medium, we can say that this is an optically rarer medium, and this second medium is an optically denser medium. So when light is traveling from optically rarer medium to optically denser medium, the light rays bends towards the normal, and when the light rays travel from optically denser medium to optically rarer medium, it bends away from the normal. So in this case, water is an optically denser medium and air is an optically rarer medium. So it will be our first case, that is light is traveling from air to water. Air is optically rarer and water is optically denser. So light rays, when it travels from optically rarer to denser medium, it will bend towards the normal. So if we summarize the answer, we'll write it as light ray bends towards the normal. Water is optically denser than air. So when a ray of light enters a water medium, its speed slows down and it comes closer to the normal. So this is the answer to the first question. Let's solve the next one. Now the second question is light enters from air to glass having refractive index 1.50. What's the speed of light in the glass? The speed of light in vacuum is 3 into 10 to the power 8 meter per second. So let us write down the refractive index of the second medium with respect to the first medium in terms of the velocities of light in the given medias. So we know that refractive index of the second medium with respect to the first medium is refractive index of the second medium by refractive index of the first medium, which is also equal to velocity of light in the first medium by velocity of light in the second medium. Now the second medium here is given glass and the first medium is air, because light enters from air to glass, that is light is going from air to glass. So glass medium is the second one and air is the first medium. So if we rewrite according to this formula, it will be refractive index of glass with respect to air is, we'll have to consider this equation because we are given here the velocity of light and we are asked to find out the speed of light in glass. So it will be velocity of light in air, that is the first medium, by velocity of light in glass, which is the second medium. Now the refractive index of glass with respect to air is given as 1.50 and the velocity of light in air, we also write it as c. So it is c by v glass. So the velocity of light in air is 3 into 10 to the power 8 meter per second and the velocity of light in glass we'll have to find out. So let's rewrite this. Velocity of light in glass is 3 into 10 to the power 8 meter per second divided by this 1.50, which is 300 by 150 into 10 to the power 8 meter per second, which is 2 into 10 to the power 8 meter per second. So the answer is the velocity of light in glass is 2 into 10 to the power 8 meter per second. So this is the answer to this second question. Let's now solve the third question. The third question is find out from table 9.3 the medium having highest optical density. Also find the medium with the lowest optical density. So here we have the table of absolute refractive index of some material. So absolute refractive index means the refractive index of these given medium with respect to air. So now the refractive indices of all these mediums are given over here. And looking at the refractive index, we can know what will be the optical density of that medium. How? It's like the medium with the maximum value of refractive index will be having the maximum optical density. The medium with the highest refractive index will have the highest optical density, and the medium which has highest refractive index or highest optical density, in that medium the light will travel the slowest. That is, speed of light is inversely proportional to the refractive index of the medium, or it's inversely proportional to the optical density of the medium. That is, the media whose refractive index will be maximum, the speed of light will be minimum in that medium. That is, light will travel the slowest. Okay, so now that whose optical density is maximum, the speed of light will be least in that medium. Alright. So now looking at the value of the refractive index or the optical density, we can say the speed of light will be more or less in that media. So here we are asked to find out the medium with lowest optical density. Now in order to find out the medium with lowest optical density, we'll just have to look at the medium with the lowest refractive index. So that will be the medium with the lowest optical density and the highest optical density. So as you can see here, air is having a refractive index of 1.0003 and the refractive index of these mediums like ice, water, alcohol, kerosene, it goes on increasing as we go down the list. So as you can see, the maximum refractive index is diamond. So diamond will have the maximum optical density or the highest optical density. So as per the question, to find out the medium having the highest optical density, it will be diamond. Okay, so highest optical density will be diamond and the speed of light will be slowest in diamond. Similarly, the medium with lowest optical density will be the medium whose refractive index will be the least, and it's air in this table. So the lowest optical density will be air. So this is the answer to this question. Let's solve the next one. The next question is, you are given kerosene, turpentine and water. Which of these does the light travel fastest? Use the information given in table 9.3. So as I've said you earlier, light will travel fastest in the medium which has the lowest refractive index. Alright. So the velocity of light in a medium is inversely proportional to its refractive index. So the medium whose refractive index is the least, light will travel with maximum speed in that medium and vice versa. So let's see, in kerosene, turpentine and water, whose refractive index is the least, light will travel fastest in that medium. So let's see here, kerosene has a refractive index of 1.44. Turpentine has a refractive index of 1.47, whereas water has a refractive index of 1.33. So the refractive index of water is the least. So thus we can conclude that the speed of light in water will be maximum. Okay, because it has the least refractive index. Alright, so the answer should be water. With a refractive index of 1.33, the speed of light will be maximum in case of water. So this is the fourth question. Let's solve the next question now. The next question is, the refractive index of diamond is 2.42. What is the meaning of the statement? So first let's write down what is the meaning of this question. So the refractive index of diamond is 2.42. It means the refractive index of diamond with respect to air is 1.52. That is, the absolute refractive index of diamond is 2.42. As per the formula for refractive index, the refractive index of second medium with respect to first medium is the refractive index of the second medium by the refractive index of the first medium, which is also equal to velocity of light in the first medium by velocity of light in the second medium. Now let us understand this question in terms of this equation. So refractive index of second medium with respect to first medium as per the velocity of light is the velocity of light in the first medium by velocity of light in the second medium. So here the second medium is diamond and the first medium is air. Now the velocity of light in air by velocity of light in diamond, which implies the refractive index of diamond is 2.42, which is equal to the velocity of light in air by the velocity of light in diamond, which implies that C is equal to 2.42 into Vd. That is, the speed of light in air is 2.42 times more than the velocity of light in diamond. That is, the velocity with which light travels in air is 2.42 times more than the velocity of light in diamond. Okay, so we can say that light travels 2.42 times slower in diamond than in air. So the velocity of light in diamond will be C by 2.42. So the answer to this question is, the meaning of this statement is that light travels 2.42 times slower in diamond than in air. Alright, so this is the answer to this question. So now we have solved the questions that are given in this set. If you want to know more about the optical density, I have already made a video on it which is in my channel. I'll place the link of that in the description box. You may watch it. It will help you a lot in understanding optical density. So I hope you have understood the answers to all these questions. If you have any doubt at any part, you can ask me in the comment box. So this was all for today. If this video was helpful to you, please like it, share it, and if you are new to this channel, Request you to please subscribe to it. Thanks for watching. Bye bye. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I have shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.